Yeah, good morning students. So today in class 8, chapter number 12, exponent and powers. In this chapter we will learn to how to represent the very large number and very small number by using the exponent and power. Like suppose you write a number like mass of earth. The mass of earth is 5970 kilogram. So you can see this is a very large numbers. Okay. So generally we can't use these type of large number in our calculation. It is very difficult though. So we have to convert these number in different form. And this is called by using exponent and power. So first of all, in class 7th you have understood about the exponent and power. So let's revise some topic here. Suppose there is written 2 raised to 5. So what is the 2 raised to 5? 2 5 times. 2 multiply 5 times. Right? 1, 2, 3, 4, 5. So this type of number we can represent in form of power and exponent. You know this 2 raised to 5, 2 is called base and 5 is called exponent. And this complete 2 raised to 5 is called power of 2. So this is the basic knowledge of exponent and power, and you have learned in class 7 earlier. So now you have to see here that what we will learn in this chapter in the class 8. Actually in this class we will learn how to represent very small numbers in our daily life. So like suppose a number is written as 0.205070. So this type of numbers we will learn how to represent in easy manner. So before this we will learn something here, and that we will learn the power with negative exponents. Powers with negative exponents. Power with negative exponents, it means if there is a written 3 raised to minus 2. 3 raised to minus 2. So what is the meaning of this 3 raised to minus 2? That we have to understand. So first of all, before this question, we have to understand in simple manner. Suppose I am writing 10 raised to 2. It means 10 into 10. 2 times, right? You know earlier. Now suppose you write 10 raised to 1. I am decreasing the exponent by 1. So it means 10 multiply 10 divide by 10. So it will be 10. Suppose I am writing 10 raised to the power 0. Again I decrease the power exponent by 1. It means 10 will be divided by 10 and it will be 1. Now again suppose I decrease the power exponent. So 0 after 0 negative number minus 1. It means again we divide by 10. So whenever you decrease the exponent by 1, it means we have to divide by the base. Base number is here 10. So whatever number is here, 10 raised to 2 is 10 into 10. So 10 raised to 1, it means we have decreased the exponent by 1. It means we are dividing the given number 10 into 10 by 10. So divide previous number by 10 each time. So you can see 10 raised to minus 1 you will got 1 upon 10. So this is the meaning of power with negative exponent. It means if someone is given you 10 raised to minus 2, then you can write 1 upon 10 into 10. Right? Or you can write 1 upon 10 into 1 upon 10. Both are correct. Suppose somebody write 2 raised to minus 5. So you will write 1 upon 2 into 2 into 2 into 2 into 2. 5 times. 1, 2, 3, 4, 5. So this you can write So this is the meaning of negative exponent, power with negative exponents, negative exponent, right? So I think you have understood how can we represent the negative exponent. Actually, what is the negative exponent is given, we can write here 1 upon 5 into 5, and 1 upon 5 into 5 means 1 upon 5 raised to 2. So it means you can see here, if negative exponent is given, then you can convert in positive exponent by its reciprocal, by doing its reciprocal. And the formula is here, a raised to m is equals to 1 upon, this is minus, a raised to minus m is equals to 1 upon a raised to m, and 1 upon a raised to m is equals to, this is the complete formula here, you can see. And if a raised to n is given, then you can write minus 1 upon minus a raised to m, negative power. So a raised to m is equals to 1 upon a raised to minus n. It means we have to just change the exponent sign, right? If it is given in positive, negative, you can make it positive if required. If it is given positive, and sometimes you require negative exponent, so you can write here 1 upon a raised to minus n. So this is the basic knowledge with related to power with negative and negative exponents. Let's see forward. There is a try this question 194 page number. Find the multiplicative inverse of the following. Multiplicative inverse of numbers. So suppose this is given 2 raised to minus 3, then you can write here 1 upon 2 raised to 3. Clear? By using the formula. So you can do this question. Sometimes we have given decimal number like 5.2. So how can we write 5 plus 2 upon 10? And 2 upon 10 can be written as 2 into 10 raised to minus 1. So 5.2 can be written as using the negative exponent here, like 5 plus 2 into 10 raised to minus 1. Suppose a number is given 2.65, then you can write 2 plus 6 upon 10 plus 5 upon 100. You know this is a decimal chapter knowledge. So plus 6, already you know. So now we are learning just only changing this denominator into the exponent form. 6 into 10 raised to minus 1. Plus 5 into 10 raised to minus 2. So this is the use of negative exponents power in our daily life. We can represent a number in very easy manner in the form of power and exponent. Now you are thinking that why we require to learn this thing. So I am taking a question one here. Suppose sometimes there are very small charge of neutron is like 0.0567 into 25. So how can you represent this type of number? This is very small number. Or you can take 0.000005. So how can you write this number in easy manner? So you have to count first 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So you can write 5 into 10 raised to the power. Okay, you can remove this point and you can write here 10 raised to the power 10. So 5 upon 10 raised to the power 10 can be written as 5 into 10 raised to the power minus 10. Clear? So this is the use of the power with negative exponent that you have learned here. So do practice with this type of questions. You can try this on the page number 194, expand the following numbers in using exponents. Now we will learn what are the laws of power and exponent in this chapter, and that by using that laws we can do calculations. So we write here laws of exponents. These laws of exponent you have learned in class 7th also. Okay, so I am just using that knowledge so that you can learn better. First law is a raised to m multiply a raised to n is equals to a raised to m plus n. Right? This formula you have learned in class 7. Same formula I am using here. Let's see how. 5 raised to minus 2 multiply 5 raised to minus 1. So you can see here that the base is same. The base is same. So then our exponent is different. So by using this law, you can write 5 raised to minus 2 plus minus 1. You know this is a integer chapter knowledge. You have to write the negative number in brackets whenever you are adding or subtracting or multiplying. So now you can see it will be 5 raised to, both are negative numbers, so they will be add. So 3 and sign will be negative. Don't do here minus minus plus. Then minus minus plus we will do in the multiplication. So we are just adding here. So you have to write both the numbers are negative, so negative sign. Now second question, second row, if a raised to m upon a raised to n, then equals to a raised to m minus n. So how we use? Suppose 7 raised to minus 5 upon 7 raised to minus 2. So you can write 7 raised to minus 5 minus 2. So whatever exponent here, you can just subtract from the above exponent. So 7 raised to minus 5 minus minus plus, minus into minus plus. So it will be plus 2. And this will be opposite sign, so we will do subtraction here. 7 raised to minus 5 plus 2 minus 3. So in this manner you can use the laws of exponents to solve the calculation related to the negative exponents. Now third formula is a raised to m bracket whole power n. So it will be a raised to m multiply n. So example like 3 raised to 4 minus 4 whole power minus 2. So 3 raised to minus 4 multiply minus 2. Now here we have to, you can see very easy, minus 4 multiply minus 2. Okay, so just you have to keep in mind that we have to use negative sign with number also, with power also. Okay, so 3 raised to minus 4 into minus 2, minus into minus plus. So plus 4 into 2, 8. Here we have to multiply, right? So 3 raised to 8 is the answer. Other type of question like this, 4 raised to minus 2 whole power 3. So here is negative exponent, but here is a positive exponent. So there is the same rule, no change. You have to write 4 raised to minus 2 multiply 3. 4 raised to minus 2 into 3 minus 6. So these are the very easy questions. If you do practice by keeping the formula in the mind, first you use simple question, then you have to come to the next level. Now you will solve the page number 195. Try these questions that we have discussed. Let's take one question. P raised to 3, P raised to minus 10. p raised to 3 into p raised to minus 10. So you can see here the base is same. So which law will apply here? Think about this. First, second or third. Yes, think about this. Whenever base is same, then which law will apply here? Yes, absolutely. First law will be applied here. So we use this formula. First, we write a raised to m multiply a raised to n is equals to m plus n. So by using this law, we can write p raised to 3 plus minus 10. So whatever number is exponent is given, you have to take with the sign minus. Otherwise, it is given positive, then positive. So p raised to the 3 plus minus minus plus into minus minus. So minus 10. So 3 minus 10, what is? 3 minus 10 minus 7. So this type of, if you use very slowly and we use the first formula, then you have to come to the easy question and then you have to test with the question. So before you writing something, you have to just understand the formula. What is the basic behind the formula? The basic behind this formula is that whenever the base is same and whatever exponent is given, that will be added together. So on page number 195 in the below, you are given five formulas. First we have covered, second we have covered, third we also covered, and third we have not covered. Okay. So let's take for a raised to m into b raised to n. In this formula you have to see this looking very similar to first formula, but see very carefully, here base is different and the exponent is same. So this formula is different. So base is different, but the power exponent is same. So you have to write a into b together whole power m. Okay, don't add exponents here because we have combined the base together. So let's take example like 2 raised to minus 5 multiply 3 raised to minus 5. So you can see the exponent is same. In this formula, you have to keep in mind that exponent is same, but the base may be different, may be same, no problem. So 2 raised to the 2 into 3 together, 2 into 3 together, and exponent 2 into 3 6 raised to the power minus 5. So you can see this is very easy chapter. If you understand the topic very carefully, what is the basic behind this topic, and if you understand the formula with the question help, then you can use this again and again. But do practice, very important. One more little very small formula is remaining. Okay. 4. Now we have to remove this. Now see here. So this is a fifth formula. Numbering is changed, but I am covering all the formulas. So a raised to m upon b raised to n. So here you can see base is different, but the exponent is same. So we will take combinedly a upon b, and exponent will be same. Don't do any subtraction here because we have covered a base. Different base, two different base together as a fraction form. Let's take an example like 2 raised to minus 3 upon 3 raised to minus 2. Now this question you can see very carefully. So here we have to take this exponent same. So 2 upon 3 combinedly we can write, and the exponent will be minus 3. So this is very easy question, you can understand here, and these are the laws of exponent that you have to cover here. One is more, a raised to 0 is equals to 1. That you understand already in class 6, 7. So whatever number here, it may be 2 raised to 0, so it will be 1. It means if any number has an exponent 0, then its value will be 1. Okay? So we have covered all the laws. So remember, there are 5 basic laws that we have covered here, right? one more I have given that is very important, that we have got in the starting, right? Now you can solve all the examples, see the example, take the help of examples which on page number 196, and then you have to come to the exercise. In the exercise question, similar question I have taken here. So let's take us some typical questions. Okay, let's take fifth question of third. This is a very different type of questions. Actually, when you solve the easy question, then after you have to read the next level. So I am taking a one question here from exercise 12.1. So let's see how will you understand this question. So first of all, you have to see this question very carefully. There is given minus 2/3 as a combined fraction number, and whole exponent is minus 2, and thereafter also exponent is 2. So first of all, let this minus 2/3, let minus 2/3 is equals to a. So what it become? It is become a raised to the power minus 2 whole power 2. You can see, if we let this minus 2/3 as a single number a, then the question will change in this form. Now you can see it's looking very easy question. So you can see exponent or exponent. So which formula we will use here? We use a raised to m whole power n is equals to a raised to the m into n. Okay. So this formula we will use here. So it becomes a raised to the power minus 2 into 2, and it becomes a raised to the power minus 4. And now you will put the value again of a. So what is a here? Minus 2/3. Minus 2/3 in bracket and whole power minus 4. So now you can see here what we have to do. We have to find the exact value. There are two types of question. One is simplification question, one is find the value. So in simplification question, we will not calculate the actual value. We will just simplify using the laws of exponent. But in the finding the value, we have to just solve completely. Like suppose 2 raised to 3 is given. So 2 raised to 3 we know 8. So that is the solution of the finding value. So minus 2/3 whole power minus 4. So we have to use combined here. I will derive minus 2 whole power minus 4 upon 3 whole power minus 4. So minus 2 separate we have done here. And which formula we use here? A raised to m upon a raised to n. So this is not a upon b whole power m equals to a raised to m upon a raised to n. This formula we have used here. Now what we do here? We solve this minus 2 raised to power minus 4. So minus, if you note down here, if there is a negative with number, and power is even, then it will become positive. Even exponent. And if it is a negative, odd exponent, then it become negative. Okay. So here is given minus 2 whole power minus 4. So minus 4 is a even number, you can see. So it becomes 2 raised to minus 4. And here is 3 raised to minus 4. So there is no problem. So we can write here 2 raised to minus 4 upon 3 raised to minus 4. Now, what we will do? The first formula we will apply here. What is? A raised to minus m is equals to 1 upon a raised to m. It means we change we do the reciprocal. So, 2 raised to minus 4 will come as a denominator, 2 raised to 4, and 3 raised to minus 4 will go as a numerator. So it will come here 3 raised to 4. And now we will solve here. What is 3 raised to 4? 3 into 3 into 3 into 3. And what is 2 raised to 4? 2 into 2 into 2 into 2. So 3 is a 9, 9 is a 81. 81 upon and 2 to the 4 is 16. So 81 upon 16 is the answer. So this time you are when you solve, when you do practice and when you understand these basic formulas, first you have to do practice with on the formula. Then you will solve this type of questions. Directly you can't do these questions. So first of all, whatever I discussed earlier in this video, you have to just revise and see again that formula wise practice you have to do, and then you have to come to this type of logical questions. So this type we can use more than one formula. You can see here we have used how many formula? 1, 2, 3 and 4. 4 formula we have used in this question. So do this practice, okay? One more question we want to take here. Simplify. This is the question of number 7. Simplify. Simplify. Question number 1. 25 into t raised to minus 4 upon 5 raised to minus 3 into 10 into t raised to minus 8 and t not equals to 0. So t cannot equals to 0 because t in the you know why it is given, because 1 upon 0 is not defined. So this is given. Everybody know? 1 upon 0 is not defined. So it is given. So 1 upon t cannot be equals to 0. So now we have to solve this question here. So first of all, we will solve like 25. 5 raised to 2. T raised to minus 4. Upon 5 raised to minus 3. And 10 we can write 2 raised to 1 into 5 raised to 1 into t raised to minus 8. It means what we have done here, whatever number which can be represented in the form of prime factor form, that we can change in the form of exponent. Okay. And now 5 raised to 2 will be upper side and 5 raised to minus 3 will go upper side. So plus 3. Okay. This number will go their side. T raised to minus 4 and 5 raised to 1 is also. So it is minus 1. Clear? Plus 1. So minus 1. And t raised to minus 4. Here is minus 8. So it becomes plus 8 on upper side. And into 2 raised to 1. So it becomes 2 raised to minus 1. We include this number minus 3 as a positive plus 3 because we know which formula? 1 upon a raised to minus m becomes a raised to m. So 5 raised to 2 plus 3 5, 5 minus 1 4, t raised to 8 minus 4 4 into 2 raised to minus 1. So that we can simplify this formula 5 raised to 4 into t raised to 4 upon 2 raised to 1. This is called simplification. Okay. So I have discussed here one question of solve and one question of simplification, and that you have to understand, that you have to do practice. Now we come to the next topic. Which is use of exponent to express very small number. Okay. So this topic is use of exponent to express small numbers. Standard form. Standard form of very small numbers. So what is the meaning of standard form of very small number? First of all, we have to understand. You know the distance from the earth to sun is very large number. The speed of light is very large, very big number. So this type of number, how can we represent? So let's see a number. Suppose 5. number, we can write here 5.0 into 1, 2, 3, 4, 5, 6, 7, 8, 9 into 10 raised to the power 9. So this is an easy way. In this future you will do in maths, chemistry, biology, physics, you will see some numbers in this form. Okay. So remember, this chapter is very important. Now this is very big number. Now very small number like 0.00005. So how can you represent this number in very easy manner? So let's see here. First remove 0 point and one write 1, 2, 3, 4, 5, 6. So 10 raised to the power 6. Or you can write 10 into 10. This time we will not write in this chapter, okay? Because this chapter is we using calculation easy, not difficult. So we write here how many tens here? 1, 2, 3, 4, 5, 6. So 10 raised to the power 6. So this number is become 5 into 10 raised to the power minus 6. So if the number is very small, then here will be negative exponent. If number is very big, then there will be a positive exponent, right? Yes, right. So let's see one more question. Suppose 0.000007 0.007, how will you represent? 72. Yes. So in standard form, you have to understand that we will use whatever number we are writing, the decimal will be after only one digit. After only one digit. You can't write here like 52.0. You can't write here 0.52. So it is wrong. It is right. So this is called standard form. In standard form, whatever number you will write will be starting digit on unit place. Okay, and after this you will write the point, right? So suppose you have given 250. So what you write? 2.50 into 100 and 2.50 into 10 raised to the power 2, because here is 100. Suppose number is 0.250. So what you write? You will remove point 1, 2, 3, 1, 2, 3. It means 10 raised to the power 3. So you want to bring point here. So whatever you point here, 2.50 upon 10, right? Into this point is removed here. This point, okay, let's see again. Suppose point is here, okay? So what you write here? You will write 250 upon 10 raised to the power 3. Correct? Now you have to not write 250 here like this. You have to write 2.50 into 10 raised to the power 2 upon 10 raised to the power 3. It is already here. I have not changed anything. So 2.50. It means after one digit you have to write decimal number. Okay. Whenever you are changing in standard form, whatever is very small number, very big number. Now 10 raised to the power, you can see 2.50 into 10 raised to the power 2, and this 3 will go upside here with negative sign. So 2 minus 3. So 2.50 into 10 raised to the power 2 minus 3 minus 1. So this is the standard form of the given number decimal. Clear? So you will do this practice, but keep in mind that in standard form, after one digit, unit place digit, the decimal will apply. And write this one. This is very important. You can't write 52.0. You can't write 0.52. You have to write one digit, point. Then after you can use as many digits given in the question. Okay, let's take one question more so you can understand better. Yes. Suppose question is given 1524000. So you will write here 1.5. You will write here point 1.524. Okay. And after this you can write 10 raised to the power 1, 2, 3. and this one you can write 10 raised to the power 1, 2, 3, 4, 5. So it becomes 1.524 into 10 raised to the power 8. Right? So in this type, you can see again, I have changed, write either only one digit, then after point, then after whatever digit is given, then you can solve this question. Let's take one more question. 2045000. So here you will write 2.045 into 1, 2, 3. 10 raised to 3, and this you can write 1, 2, 3, 4, 5. So 2.045 into 5 plus 3, 8. So this is the answer. You can see very easy. If you do practice, you understand the topic, then you can do better. Now a very last topic is remaining here. What is the comparing of very large and very small number, that you have to understand. And this will be useful in the numericals of physics and chemistry, biology in your classes like 9, 10, 11, 12. Whatever topic we are going to study here. So how can you compare the bigger number? Like suppose we have given 1.4 into 10 raised to the power 9 and compare 1.4 into 10 to the 9 and 1.273 into 10 raised to the power 7. So how can you compare this type of number? You have to just write 1.4 into 10 raised to the power 9 upon 1.273 into 10 raised to the power 7. Now you can see 1.4 and 1.273 is near about same, approximate same. So don't consider this number. Consider only this number, 10 raised to the power 9 and 10 raised to the power 7. So when you use 9 minus 7, because according to formula you will get 10 raised to the power 2. It means if this number is A and this number is B, so it means this is 10 raised to 2, right? So A is equals to B into 10 raised to the power 2. It means A is 100 times of B. A is 100 times of B. So you can see how we compare two numbers which are given in exponent form in this type. You have to just write upon form, right? You can say fraction form or ratio form, whatever, and try to change these numbers, these decimal numbers approximately same. Like suppose it is given 12.73. Then what do? You can write here this point. You will bring this point here. So you are making a large number into a smaller number. So you will make here 10 extra. Okay. So now it becomes 1.2 again 1.27, and now we can consider as an approximate equal. So now it becomes 7 plus 1, 8. Right? I am doing in the previous question so you can understand better. So 9 minus 8, and this is 1. It means this is only 10 times. It is only 10 times. So this type of calculation, this type of changes you can do to understand better. Right? So this chapter is complete and you have to do practice. One more question we take here, like for 12.2, express the following number in instant form, that we have covered here. Express the following number in usual form. Usual form is nothing, you can see here, just removing the exponent. Like suppose is given 2.53 into 10 raised to the power minus 5. So you can write 2.53 upon 10 raised to the power 5. And when you divide by 10 raised to 5, this number will become like this, point will go that side. How many places? 5 places. So 1 is already, we have got here, from here, 2, 3, 4, 5.0. So this point will come here. So this is the usual form. Usual form means simple form, you have to solve the number. So this chapter is complete. Do practice and take the help of examples and see this video again and again. Okay, this is a complete one video of this chapter 12 exponent and power. Okay, thank you.